Okay, pre-calculus, here we go. The big day, we're going to talk about the derivative today. This is real deal calculus. In calculus, a theme you will definitely study a couple of times is the rate at which certain quantities change as you go through a function or some kind of an application. One rate of change that you have studied repeatedly is the slope of a line. For years you've been studying that. It gives a number to the rate at which the y value on a line changes for some kind of a change in the x value. Now a curve like a parabola can't be described with a slope. I think you guys know that by now, because the rate at which the y values change in a parabola constantly changes. It's not constant. The only graph you have where the slope is constant is a line. In fact, for half of the graph, the rate of change is positive for a parabola, and the other half it's negative. Okay, so here we go. Definition, a tangent line. We talked about this in class, I think. It's a line that intersects a curve in only just one place. Okay, so I'm going to draw a swooshy with a hoop-de-doo. There you go, swooshy with a hoop-de-doo. And I'm going to put a point right there. Now I'm going to draw a tangent line to this curve. So that's a line that just comes through and just hits this in one place. That's what a tangent line looks like. And here we'll do kind of a square root function looking thing. We'll put one point right there, and we'll have do our best to draw a line that just intersects that curve in one place. This is the graph of f of x, and that line is called a tangent line. Now, one way that you could describe the rate at which a curve is increasing, not a line, but a curve. How could I describe how this curve is? Well, this one's decreasing, that one's increasing. Is to focus on an individual point, like the ones that I put on this graph. Draw a tangent at that point, and then give the slope of that line. That slope would be describing how steep the curve is just at that one point. We're going to refer to that, of course, as an instantaneous rate of change. Ready? So let's just write that down here. An instantaneous rate of change. What do I mean by that? I mean, don't go anywhere else on the curve. Just stay in that one spot right there, and that's how the curve is, in this case, decreasing. And that's how steeply this curve is increasing. If I move the point, the rate of change is going to move, right? Get both of them. Well, this would get more steeply negative, and this one would flatten out and become less steep. Okay, there we go. We're in it now. Let's go, calculus students. Of course, the slope would be different at any different point that's on that curve. And so now we got the big giant question. If the formula for slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which definitely requires 2 points, so that you can see how much the rate is changing, how are we going to find a slope at one point when the slope formula requires 2 points? That's the big giant question. The answer, of course, is with a limit. That's why we've been talking about this for 4 days. Okay, so definition, a secant line. We're using trigonometry names here. A secant line intersects a curve or a circle, you learned this with circles before, at 2 points. Not just 1 point, 2 points. So let me draw a little parabola in here. It doesn't have to be a great drawing, and I'm going to put a point here, and I'll put one over there. When we have this line intersect with both of those points, that's a secant line. So we're going to use the concept of a secant line with 2 points and kind of turn it into a tangent line. Here we go. We're going to describe the second point in terms of the first point. This is the magic right here. I'm going to have a point x, f of x on my graph. So I'm going to start at the origin, and I'm going to finish up here, and I'm going to it'll be like a slow exponential function. That's what I got going on there. All right, there's the graph of our function. Now what I want you to do is pick a point down here, like maybe here, and put that as an x. When that goes up and hits this graph, it comes over and there's a y value that goes with it, and I will call it f of x. Okay, so let's make a big deal out of the point right there. And then here, I'm going to go down here, and I'm not going to call that x2. I'm going to call this x plus h. So I have this distance h here in horizontal distance in between x and this point. So now when this goes up and hits this line, the curve, sorry, when I come over here, that y value would be called f of x plus h, wouldn't it? So I got this like maybe call it 5. So if this is 2, that's 7. And so this would be f of 2, and that would be f of 7. You see my point. So my second point will be x plus h and f of x plus h. Okay, so let's make a big deal out of this point right here. I've got 2 points. Sorry, keep moving it. X f of x and x plus h f of x plus h. That's my setup. Here we go. Right into page 3 where we're going to bring a limit in here. Am I still in focus? I am. So my points, let me just rewrite my points since I flipped the page. X and f of x, and then also x plus h, sorry about that, and f of x plus h. Those are my 2 points. Man, I had a hard time writing that. Look how ugly that is. Okay, then the slope of the secant line is, ready? Slopes go y equals m equals y2 minus y1 over x2 minus x1, right? Right? Isn't that how slope goes? So here we go. M equals that y value, f of x plus h, minus that y value, f of x. And it'll be over this x value, x plus h, minus this x value, x. That is the slope of the secant line with my 2 points. Now if you look at the denominator, there's an x and there's a minus x. Those will cancel out. So I can simplify this a little and say the slope of the secant line is f of x plus h minus f of x. And since the x's cancel, it's over h. Okay, that is a formula for the slope of the secant line. The formula for the slope of a secant line actually has a fancy name. It's called the difference quotient. A lot of pre-calculus books, including this one, like to give problems about the difference quotient in the first chapter to see if you can handle that notation. I like to skip that until now because I think it's kind of needless in the middle of the first chapter. I didn't really have to tell you that, did I? Anyway, now think of what happens to this whole situation as h, which is the distance between x and the second point, that h. Let me take this, let me go back to my picture here that we just did a second ago. This h is this distance between these two. What happens if h gets smaller? If h gets smaller, we're getting closer to this x value, so that means this point's going to come down this curve and get closer to this point, right? Okay, so I'm going to kind of draw that out for you. I'm going to put, let's see, I'm going to put a point here on both of these when x is equal to 1. And we're going to say that's x. There you go. And then I'll start with this point here at maybe 3.5, and I'll say that's x plus h. And so there's my h. But now I'm going to put a point here where x is equal to 2. Okay, so now this is my x plus h. Got to draw it real small because this is my smaller h. Now look, what's happening is the point is getting closer and closer to the original point, right? So now think about the limit of f of x plus h, f of x plus h minus f of x over h as h approaches 0. So if you think of the limit as h is getting closer and closer to 0, this distance is getting closer and closer to disappearing, and so that point is getting closer and closer to becoming the original point, or landing on the original point. And what happens is the slope of the secant line, the difference quotient, becomes the slope of the tangent line, which is what we were after in the first place. So if I take a limit of this expression as h closes in on 0, then that limit is the perceived destination, right? And so it would stop being a secant, and I would have the slope of the tangent line. Let's move on to page 3. Sorry, page 4. This is our last page already. Look at that. Now that you're calculus students, you're killing it. Okay, the slope of a graph. Here we go. The slope m of a graph of a function f at a point x comma f of x is equal to the slope of its tangent line where it's tangent at the point x, f of x. Okay, so that's the story we've been telling for 4 pages now. The slope of a graph is basically the slope of that tangent line at that point. And it goes like this. That slope is given by the limit as h approaches 0 of a fraction that goes f of x plus h minus f of x. Remember, those were our 2 original y values from our picture, over h. For which direct substitution would give us 0 over 0. If I put a 0 in for h here, I got f of x minus f of x. And if I put a 0 in here, I just get 0 over 0, which would be undefined. So what's going to happen to us is we're going to have to actually substitute a real function, like x squared, into this slope formula and simplify it so something cancels so we can find the slope at the point negative 2, 4. All right, here we go. This is your first problem at finding the slope of a tangent line. Find the slope of the graph of f of x equals x squared, the parent function parabola, no big deal, at the point negative 2, 4. Ready? Here we go. M equals, the slope equals the limit as h approaches 0 of, now if it's f of x plus h, isn't that going to be x plus, we just substitute x plus h into the equation. So I put x plus h in here, and I get x plus h being squared. Minus f of x is just the function the way it is, so it's just an x squared. And that's all over h. I just want you to look at that and take that in and make sure you understand what just happened. This is the formula that works for this slope thing every time. So no matter what kind of equation you get, what you want to do is put x plus h into that equation first, write out whatever it is, then put your subtraction sign, then put the function, whatever it is, the way it is, and put it over h. Now here's what we're going to do. We're going to hopefully simplify so this h isn't in the denominator. I'm going to multiply this out. X plus h, I'll do it up here, even though you've done this 1,000 times so you know exactly what this is. It's going to be x squared plus xh plus xh plus h squared. So it's x squared plus 2xh plus h squared. And couldn't I got that from this, right? Remember the old binomial theorem? Remember that? Oh, look at that. Okay, so anyway, the slope is the limit as h approaches 0 of, I just changed the numerator. I multiplied this out and I get this, x squared plus 2xh plus h squared minus x squared over h. Where did this x squared come from? It's this one right here. So I multiplied this out and I got these 3 terms, and then I still have a minus x squared. Now look what happens. That x squared and that x squared actually cancel. So this is the limit, which we'll deal with this limit in a little bit, of, if the x squareds are gone, this is 2xh plus h squared over h. Now that the x squareds are gone, everything's got a h in it, we can factor and cancel. And then the h won't be in the denominator anymore. Once the h is not in the denominator anymore, I can evaluate the limit with direct substitution. So do a little curvy arrow and go to the top. This will be the limit as h approaches 0. Yes, you got to write the limit every time, you goofballs. And so let's just factor this h out. Both of them have an h, so I'm going to use the distributive property to take out an h. What's left in the parentheses? 2x plus h. Okay, and then what's in the denominator? An h. And now that this has been factored out, those are going to cancel, aren't they? This slope is the limit as h approaches 0 of just 2x plus h. Now I can substitute 0 in for h, and when I do, that's going to be 0. This is just 2x, isn't it? Isn't the slope just 2x? If you put a 0 in for h, it's just gone, and you get 2x. Okay, so we're almost done with our answer. Slope at the point negative 2, 4 goes like this. I got my slope formula. It's 2 times x, so I'm going to put my x right there. And I get negative 4 as a slope. The answer to that whole problem is negative 4. That's it. That's the answer to the whole problem. Now, if you want to see what I mean by that, this is the parabola, parent function parabola, and we're saying at the point negative 2, 4, The slope is -4. Look, I'm just going to bring a scrap of paper in here and I'm going to show you exactly what I'm talking about. There is the parabola that we just discussed, x squared. There is a point -2, 4 on this graph, -2, 4. Put in -2 squared, you get 4, right? What I'm saying is that this line that is tangent to that parabola at that point has a slope of -4. That's what you guys just found. Now, I drew mine a little wider so it doesn't look like a slope of -4. It would be taller and skinnier if you did this on a calculator. All right, there you go. This is your first big step in calculus, is finding the slope of a tangent line that is tangent to the graph of a function if I give you a point. Now, what do we have to do? We had to go through all of this to find the equation of the slope right here. This right here is a slope equation. And what we did with it is we took the point they gave us and we actually put something in for x. All right, there it is. Here's your last example for the day. Find the slope of the graph of f of x equals -2x plus 4 at the point 5, -6. Okay? Slope is the limit as h approaches 0 of, now I'm going to go back to my original formula here. Here's my original formula. I've got to put -2x plus 4. I've got to put x plus h in for x right there. I'm making a fraction out of this. I'm going to have a -2, and then instead of x, it goes x plus h, and then there's a plus 4. Okay, that's just this part. So I'll put a big bracket around it. Then there's a minus, and then I have to do this part. So I have to take this function as it is and go -2x plus 4. And then what goes in the denominator? Nothing but an h. Now I cannot directly substitute 0 in, because if I do, I'll get -2 times x plus 4 minus -2 times x plus 4. I'll get 0 in the top and 0 in the bottom, which is not defined. Frequently in calculus, what happens is you get 0 over 0. It means you need to simplify and then evaluate the limit. So let's distribute this negative and just see what happens here. So the slope is the limit as h approaches 0 of, a big old fraction bar with an h in the bottom. I have -2x. There's also a minus 2h. There's a plus 4. This minus this -2x turns into a plus 2x. And this minus this plus 4 turns into a minus 4. Now look how much stuff cancels. The 4's will cancel. The -2x will cancel. And I simply have m equals the limit as h approaches 0 of -2h over h. And the h's cancel. So the slope is just simply the limit as h approaches 0 of -2. Well, now there's no place to put a 0, so the limit is just -2. It doesn't matter what point this is. I got the point 5, -6. I try to put 5 in. There's no place to put it in for x, so I get a slope of -2. That should make sense to us. Think of that last example for a second. Of course it's -2. The graph, you guys, is a line, and the line has a slope of -2. So if it's a line with a slope of -2, oh, let me get my piece of, oh, FedEx showed up. We'll get rid of that. -2x plus 4, I think, is my line. So I go 1, 2, 3, 4, and then I go up like this. It was supposed to be negative, wasn't it? Isn't the slope going to be the same no matter what point you pick? So we got this line at -2x plus 4. Whatever point we pick, slope's going to be -2. All right, so I think I'm going to give you, for homework, maybe like 2 problems for you guys just to try. Use this, sort of pattern every time, but whatever function they give you, you got to put x plus h in first, then a minus sign, and then write the function the way it is, put it over h, and then simplify so you can cancel that h out of there. All right, I'll give you 1 or 2 problems for homework. Have a good day, everybody.